1. Welcome back, everybody. Okay, so let's take a look here. What is this problem telling you to do with that 3 sitting outside the parentheses? Distribute it in, right? So I'm going to take this 3, bring it here, here, and here. Okay, what does this 3 turn into? What does this 3 turn into? 27. 21. Because it is 3 to the 3rd power. It is not 3 times 3. It's 3 to the 3rd power, which is 27. What is x squared to the 3rd? Chase? Good. And then we have a y to the 3rd. Are there any negative exponents? Nope. Are there any 0 exponents? Nope. Are there any double x's or double y's or anything like that? Nope. So we're done. That's fully simplified. Okay, let's take a look at number 2. What do I have to do with this? Distribute. Just like I did with the product, I do with the quotient. Now, what does this negative 5 become? Right, positive what? Positive
16. 25.
25. Thank you, Hayden. 25. Because negative 5 squared is positive 25. Not negative 10. A lot of people try to tell me negative 10. And then somebody said, well, doesn't it move down? Wait. Doesn't it move down? It's negative. No. Why doesn't this negative 5 move down? Because it's not a negative exponent. It's a negative number, but not a negative exponent. And then we have x to the 8th over y to the, be careful, negative 4. Now, can I leave that answer? No. There's something that's not happy. What's not happy? The y down there in the bottom. We got to make it positive. So it's 25x to the 8th, y to the 4th. And now, do I need to put anything on the bottom? What could I put on the bottom? A 1, right? But I don't need that. There's my answer. Let's take a look at number 3. What is this negative telling you to do? Flip the fraction. So this is going to become. Now, I've had people question me all day. Okay, this 2x to the negative 2 is going to go to the top. Do I turn it positive when I put it to the top? No.
Well,
I don't, because this negative is what I'm using, right? I will eventually have to deal with that, right? I will eventually have to deal with this negative. But the only thing I'm doing is just flipping the inside. It's kind of like ignoring what I see in there, just flipping it. Then let's apply the rest of the exponents. All right, so to the 4th power. What does the 2 become? Oh, 16. 2 to the 4th power. 2 to the 4th power, not 2 times 4. 2 to the 4th power. X to the
negative 16.
negative 8.
Oh, yeah.
That one we multiply. I know, tricky, right? Over y to the 12. Can I leave that as an answer? No. Drop the x down. I like to put it in alphabetical order. X to the 8th, y to the 12th. Questions about those 3 warm-up problems? Okay, let's go over some homework questions. What do you want to see? Hey, number 23. All right, so this negative exponent flips the fraction, right? So that's going to become 2f to the 5th over 3, all raised to the positive 4th now. Change the question. And now we distribute the 4. So that's a 16, f to the 20. 3 to the 4th is 81. And there's my answer. Jillian? 12. Okay, now I'm going to play math doctor. I bet you had as an answer 1 over 14m to the 4th.
Which one?
No.
Which one?
What'd you have?
Not close.
Not close to it. I'm going to guess you had 38,416.
That's
1
what I
over
had.
38. Now, here's the deal. What is that -4 power acting on? Just the m. You know what it would look like if I wanted to include the 14 with it, which is what you did? Parentheses. It would look like this. You follow me? So this is just 14 is happy. M to the 4th moves down, and I think we can all agree that that n just floats off to nowhere. Does that make sense? All right, what else do we want to see? Shane? Number 14. Now, again, I always have people just like freak out at these problems and just shut down. Take it piece by piece. We are right over here. Why don't you roll in and pay attention a little bit? 2 to the 3rd is 8. A, not happy. Bring it down. 8, not happy. Bring it up. B, not happy. Bring it up. C, bye-bye. 8 times 8 is 64. Everything else is good. That make sense?
Yes.
What else? Okay. 21. So let's take a look at this one down here. Okay. Distribute that power. See, this is an example where the 4th power gets carried into both the 4 and the D. So 4 to the 4th. I don't know that one offhand. I know it's negative, but it'll turn out positive. 256. D to the 4th. You follow me there? What else? Yeah.
18.
18. Okay, just straight up multiply those.
Yeah.
Q to the
No, I didn't.
15.
I was just like making sure I did it right.
You know what else would help you on that?
What?
Looking at the answer key.
Yeah, that's true. What about number 1?
All right, let's get to our guided notes for today.
Now I'm saying.
So we've got a lot to get to today, right? I just narrowly finished the notes in my first grade class. They get extra time on that too,
Oh gosh.
because to account for the announcements, first period has like 4 extra minutes built in. What's that?
Me too.
Okay.
Did you have a question on 1?
Yeah, that's what
No, I
just hate ours.
Claire.
Yes.
No, it's not. Here. Well, he's really excited.
Oh,
All right, let's take a look here. Section 6.2, radicals and rational exponents. All right. Now, let me ask you something. I'm not even going to ask you, don't even look down at your notes yet. What is 4 squared?
8. 8.
Sorry,
4.
lost it there. 16, thank you. Right? We know that 4 squared is 16. What's it called? What's the process called working it backward?
Square root.
Square rooting it, right? Square rooting it. You square root 16 and you get 4, right? Okay, likewise, if I take 7 squared, is 49. What's the process called when I take it backward? Square rooting it. How do I know that the square root of 49 is 7? Well, you try to find a number that multiplies by itself to get to 49, right? That is the process, that is the operation of taking the square root. Try to find a number that multiplies by itself to get you that number. Like the square root of 16, you say, okay, what number can I find that multiplies by itself to get 16? Well, it's 4, right? Okay, what about 25? What's the square root of 25? 5, because 5 times 5. Now, we've taken square roots before. That's not new. But what if I had said, what is 2 to the third power? Well, isn't that 2 times 2 times 2? So 2 times 2 is 4, times 2 is 8. Okay, so that's going that way. Well, what is it called going backward? No. Cube root.
How'd you know that, Chase? What the heck?
I learned it last year.
Look at it.
No, you got the first thing wrong.
It's called a cube root. Now, how is that possible? What you're doing here is you're looking for a number that multiplies over on itself, not twice, but 3 times, because that's the exponent, right? So what number multiplies by itself 3 times over to get 8? Well, it's 2 times 2 times 2. So 2 is what's called the cube root, or in other words, the third root of 8. Similarly, if I take 3 to the third, I'm changing up colors now, is 27, because 3 times 3 times 3 is 27, right? So that is cubing the number. To work it backward, we would say the cube root, or the third root of 27, is 3. The third root of 27 is 3. So what if I change even it up one more? What if I say, okay, what about 2 to the fourth power? Well, 2 to the fourth power would be 16, right? So what's the process called if I work it backward then? That doesn't. It's called the fourth root. The fourth root of 16. And this process could keep going. Because couldn't you take something to the fifth power? Okay, so reversing that would be the fifth root of a number. And what do we do? Shh, just listen. What are we doing each time? We're trying to find a number that multiplies over on itself this many times to get to the number underneath the radical symbol, right? That's what you're doing here. And that's what we're going to be focusing on today. And we're going to be talking about how does it relate to exponents as well. So just as I had said, a number that you multiply by itself to form a product is called a square root of that product. Like 4 times 4 is 16. You can take the square root of 16 and get 4, right? Now, when we write that when we write that radical symbol, right? This is called the radical symbol. When we write the radical symbol, you know what's always there, but we never really write it? A little 2 right in that pocket. Because it's a square root. You're finding something that's multiplied by itself 2 times over to get the value inside. So in that respect, I could put a little 3 in that little corner, and that's indicating the third root. So let's do some square roots. What's the square root of 1? 1. What's the square root of 4?
2.
Square root of 9?
3.
Square root of 16, right? Because each one of those numbers, 2 times 2 is 4. 3 times 3 is 9. And you know what's written there that we don't even actually see? A little 2 for each one of those. That's like saying, you know how we have like x to the first power, but we don't ever really write that 1. Same type of thing. If you don't see a number inside there, it's like an imaginary 2 sitting there. Okay? Third root of 1. 1, because 1 times 1 times 1 is 1. The third root of 8? 2. What's the third root of 27?
3.
What do you think the third root of 64 is?
4.
Because 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So we could say the third root of 64 is 4. Now, do you have to memorize those? Like, now I would assume that you guys have a lot of square roots in your brain.
No.
Some of you. Like, some of you can recognize, like, 64. What's the square root of 64?
4.
Oh, maybe not. 8. 8. My algebra teacher made us memorize the perfect squares up to 20. That list,
What a sweat.
we had to have it in our brain. We had to do a 30-second times test to do the square roots up to or the perfect squares up to 20.
All you gotta do is just
And you had to
memorize
retake it. You had to keep retaking until you got a perfect score.
How long did it take you?
I think I got it on like the third try. Oh, but this is what I wanted to say. Everybody get out your calculators.
On the day
So I want to show you. Now, I cannot show you on my screen because my calculator looks different. Can I borrow yours real quick? Thank you. To find the third root, let's take the third root of 64. We know what it is. It's 4. But to find the third root, you guys see the X root button
Oh, yeah.
right above the square root button?
Yeah.
Type in 3. Type in the X root button. And then type 64.
I got 4.
That is saying the third root of 64.
I got 576.
No.
Card.
You are finding 3 squared 64. You didn't type the second button.
Oh, the second.
Yeah? It should look like this. Look.
Is this it?
No, that's square root. You need the X root button.
Right
Right above.
Right above it. It's a miracle.
Okay? Everybody type in.
4. Yes.
Everybody type in the fourth root of 81. Try to find the fourth root of 81.
3.
Do that in their calculator. So you type in 4 X root 81.
It's 3.
Yo, why are I
3, everybody, right?
No, you didn't.
Yes, I did.
Okay.
I didn't need my calculator. Watch this.
Give him one. Give him one, please. You're screwed. Oh, gosh.
16.
That's a good guess.
You're
though.
close. That's the square root of 256.
Wait, no. Try again, Chase.
What's the square root of 16?
4. It's 4.
Because taking 2 square roots is actually equivalent to taking a 4.
Oh.
Okay, let's take a look here. Now, how does this relate to exponents? Well, what we can say is an nth root of a number, if you put a little n in that pocket, you're talking about an nth root of a number. We can take the nth root of any number by taking a fraction exponent. We have not studied fraction exponents yet. You've never studied fractional exponents. You don't know how to do it yet. Because what fractional exponents are actually roots. Fractional exponents are actually roots. So if you have a square root, you know what that actually is? Something to the 1/2 power. If you have a third root, that's actually something to the 1/3 power. If you have a fourth root, that's actually something to the 1/4 power. Where did this number go when it went into the exponent? To the denominator of the fraction, and that's what you'll see here in a minute. Let's evaluate it a little bit more, though. So to find an nth root, we're going to be using our calculators to do this. But to find an nth root of a number, you got to also actually take into account whether the root is even or odd. Here, let me tell you what I mean here. Let's find and this is saying find the second root of 49. Is that number inside the little pocket even or odd? The number inside the 2.
2. Even.
It's even, right? I'm not talking about the number underneath the house. I'm talking about the number in the little corner. That's even, right? So what number is the square root of 49? 7, right? However, I am asking you to find the second root of 49 is, what I'm asking you there is, what numbers can multiply together to get 49? 7. Any other option?
I don't know.
Do that be the same number?
9.
49 and 1.
We got 7 times 7. Any other number that multiplies by itself to get 49?
No. There is.
There's one other set.
Frick.
-7 and -7.
Oh, okay.
Because
How am I-
negative times a negative is a.
Positive.
So what we actually have to say is if this is even, you have to write what's called a plus or minus symbol in front of it. Now, what does that plus or minus symbol actually tell you? That's actually 7 or -7. That's really what this means. Those two statements are equivalent. But we write it because we're lazy. So we write it with a symbol in front of it that says plus or minus. That symbol says plus or minus, or meaning positive or -7. Now, let's take a look at the third root of -64. Put that in your calculator and do it. -4. You know, you've been trained like robots to say, oh, you can't take the root of a negative number. That's not actually true. You can't take the square root of a negative number. Can you take the third root of a negative number? Heck yeah, you can. It's -4. You want to know why? Because a negative times a negative times a negative is a... No, a negative times a negative times a negative is a negative. So you can take the third root of a negative number. If this number is odd, you can take the root of a negative number. It all depends on whether that number is positive or negative. Or sorry, even or odd. Okay, so fourth root of 16. Chase knows it. Positive, thank you, Shane. Positive or -2. Why? Because the root is even. Now, what if I had switched this up and said the fourth root of -16? Do that in your calculator. What is the fourth root of -16? That is an error because you can't take the even root of any negative number. Just like we couldn't take the square root of a -16, we can't take the fourth root of a -16. We can't take the sixth root of a -16. You can't take the eighth root of a negative. You can't take the 10th root of a negative. You can't take an even root of a negative. You can take an odd root, but you can't take an even root of a negative. All right. We're still evaluating here. Now, when I word it like saying, okay, take the indicated root, it's different from when it's provided for you. You see how in the next set of examples, I'm not saying, okay, find the second root of 25. I am just giving you the symbol square root 25, right? That means you don't need the plus or minus. What is the square root of 25? 5. We don't need the plus or minus here because when I write it like this, mathematically speaking, and you kind of have to like learn the math language, mathematically speaking, I am saying I am only accounting for the positive root of 25. Okay, what is this 1/4 telling me? Not the fourth power. The answer is 2.
I don't know what it means, but I know it's 2.
It's the fourth root. Thank you. Yeah, fourth root of 16. The fourth root, because did we just get done saying earlier on, oh, the denominator was the number in the pocket? No, this one's just a positive. Because I didn't word it as find the fourth roots of 16. Okay. What's the third root of -8? -2. And what's the third root of 64? 4. See, I bet some of you guys are already starting to recognize those common numbers. 8, 60, especially when we're working with thirds. 8, 64. You're going to see 125 is another one too. What's the third root of 125? 5. All right, flip it over onto the back. So let's kind of summarize what we know about how roots relate to exponents. And this is what you're going to see down below here. I added one more to the list on the whiteboard. if you have a, and please put this in the margin somewhere, a to the m divided by n. I would put this like you have some space above, up top, on the back on the top of the back. A to the m over n is equivalent to. Now, this, the numerator of the fraction up in the exponent, is the power. The denominator of the fraction is what's called the root or the index. Sometimes you'll hear me screw up and say index. That's the fancy word for saying the root. That's the number inside the pocket, the index. So what I can say is actually two things. Let's apply the power first. We could say a to the m and then the n root of that number. That's what that looks like. Or it's equivalent to saying the nth root first, then raise it to the m power. Interestingly enough, for some of these problems on our quiz on Tuesday, there are two answers, two possible answers. You don't have to have both. You just have to have one, because you could write it either way. You could write it as the root first, then the power, or the power first, then the root. Okay, let's take, and that's, I guess I need to add this onto my board here. This is the n root of a to the m power, or a to the m nth root. Okay, this is something you did not learn in Math 8. Pretty much all these other ones, you had an idea. But this one's definitely not. You did not learn this in Math 8. All right, taking a look here. What does this really represent? This represents, what's this 2 telling us? The 2. The root. What's the root? The second root, or the square root of 16. Raised to the what power? Third power. Okay. Well, what is the square root of 16? 4. And what is 4 raised to the third power? 64. And you're probably like, my calculator, I can just put a fraction up there. Yeah, but what happens when that's not a number and it's like an x? You gotta learn how to do it. Not in this one, because I didn't say like find the 2/3 root of. Yeah. Okay, now I could have done this a different way. I could have said, okay, find 16 to the third power and then take the square root, but I don't know about you guys. I don't really want to take 16 to the third power. It's probably a pretty big number. Likewise, I could take the third root of 8, then square it. I could apply the root first. What is the third root of 8? And what is 2 squared? You know, similarly, I could have done, and this one's not so bad. I could have done 8 squared and then take the third root of it. That's equivalent. That's saying the same thing. What is the third root of 8? Or sorry, what is 8 squared? 64. And what do you think the third root of 64 is? 4. You get the same thing. No matter which order you apply them. The root then the power, or the power then the root. Doesn't matter. So let's finish it off just by rewriting. Now, when you see this terminology, rational exponent form. When I say rational exponent form, the word rational basically just means fraction exponent form. Okay? Okay, so this is going to be 21 to the what? What's my power? 1/3. 21 to the 1/3. What's my power? 1. What's my root? 3. So 21 to the 1/3 power. Because isn't this 21, has like an imaginary 1 up there, right? Okay, 6 to the what? 6 to the 3/5. You see how that works? The exponent is on the top. The index, the root, is on the bottom. So let's do it the other way. Now, these are the problems where I have to accept two different answers. You only need to give me one of them. Okay, this is like saying 7 to the third power, and then the fourth root of that. And all I'm doing is saying rewrite it. You don't need to like give me the number. I'm just saying change its form. Or equivalently, this is saying the fourth root of 7 to the third power. Either of those answers I must accept on the quiz on Tuesday. And then the last one here, I could say the fifth root of 20 raised to the first power, but does that really, do I need that to the first? No. Or I could say 20 to the first, fifth root of it. But again, do I need that first power? Jillian? So let me show you the type of question. Great segue, Jillian. Thank you for the lead in. What type of questions does this look like if there's multiple answers on the state test? This is an exact state test question. This happened, I think, 3 years ago in the 2019 test. Select all expressions that are equivalent, because aren't there a couple that are equivalent? Take a look. 16 to the 5 over 2. Well, isn't that the fifth root of 16? Oh, sorry, no, not the fifth root of 16. Right, the second root. Or 16 to the fifth power, and then the square root, right? Is that an option? Yep, it's right here. Is this correct? No, what did they do in this one? They flipped it. That's not right. Or equivalently, I could say the square root of 16 raised to the fifth power. Do you see that on there? What's the square root of 16? So you do see it on there.
What the crap?
Is that right? Is 8 to the... No. Now, these look really weird down here, right? Okay, maybe there's a way to work it backward. These are like bases, right? What do I do with the exponents if I'm multiplying the bases? I add them, right? So this would be like 16 to the 5.5 power. What would this one be? 16 to the what? 2.5. People, what's 5 divided by 2? So that is actually equivalent. Weird, right? That's a very hard question because this one should be doable, definitely. This one should be doable, definitely. This, are you kidding me? That makes Mr. Laverick make that face that they put that on. That's really hard. I'm guessing that they gave partial credit if you got the top two, but not the bottom one. They probably gave you like 2/3 credit if you